In this video, we present a supervision and teleoperation framework that allows an operator to monitor a robot in 3D, plan dual or single arm manipulation tasks, preview the tasks in simulation, and finally execute on a real robot. This framework has been applied to the valve turning task of the DARPA Robotics Challenge. The framework has been implemented on the Hubo 2 Plus robot, the improved DRC Hubo robot, and finally the Willow Garage PR2. By creating a robot that can perform industrial tasks such as opening and closing valves, it may be possible to avoid future disasters and mitigate the risk to human life. Turning a valve was difficult with the Hubo 2 Plus robot and required large whole-body movements that could throw the robot off balance. The new DRC Hubo robot has an additional degree of freedom in each arm, which makes object manipulation significantly easier. We have created a user interface tool called localization markers, based off of interactive markers, to allow for the quick identification of objects in an unstructured environment. The size and shape of a localization marker can be modified during robot operation, and once a localization marker has been chosen, the operator can manually align it with a full 6 degrees of freedom or use the iterative closest point algorithm to snap it to a point cloud generated by the robot. We use the constrained bidirectional rapidly exploring random tree algorithm to quickly plan whole body movements for the Hubo robot that avoid collisions and maintain constraints such as balance and closed chain kinematics. Once the trajectories have been tested in both simulation and on the robot in an open environment, they are run on the robot using our test apparatus. The test apparatus consists of an off-the-shelf racing wheel that can be raised or lowered and tilted towards the robot. The amount of force required to turn the wheel can be modified in software to test for objects that require different amounts of force to manipulate. The framework handles a limited communication link to the robot by allowing the operator to modify data rates during operation in order to stay below a target bandwidth. The framework is generic and can be used to manipulate different objects that require different trajectories, such as a one-handed ball valve instead of a two-handed wheel valve. We would like to acknowledge the help of Hubo Lab and Rainbow Company at KAIST in designing the DRC Hubo robot for this competition. If you are interested in any of the software seen in this video, please see our open source repositories at these addresses.